Here's another interview question for you. They give you a binary tree, and you should write code to validate this binary tree. You should check to see if this binary tree is a binary search tree. So once again, in a binary search tree, all the values in the left subtree of a node are smaller, and all the values in the right subtree of a node are greater than the node itself. In this example, we have this 21 over here, which is violating this rule, because all the values in the left subtree of 20 should be smaller than 20. Similarly, 4 is violating this rule because all the values in the right subtree of 20 should be greater than 20 itself. And by the way, this rule applies to every node in this tree, not just the main root node. For example, look at this subtree over here. 10 is the root of this subtree. All the values on the left side of 10 should be smaller, and all the values on the right side of 10 should be greater than 10. Now, how can we solve this problem? Well, one way is to use recursion. We start from the top. For every node, we look at its left and right subtrees. If all these values are in the right range, then we move on to the next node. We can use recursion to visit every node in this tree. However, this solution is a little bit costly because if you pay close attention, you will realize that we'll end up visiting the left and right subtrees multiple times. For example, when we visit 20, we have to look at every node in the left subtree and make sure they're smaller than 20. Now, when we visit 10 later on, again, we have to revisit 3, 6, 8, and 21. So this algorithm is a little bit costly. We'll end up visiting each node multiple times. There is a better way. We can traverse this tree, and for every node, we can check to see if the value in this node is in the right range. What do I mean by that? Well, let's start from the top. If this was the only node in our tree, what would be the range of values we could store in this node? We could store any numbers from minus to plus infinity. There are no limits, right? Now that we have 20, all the values on the left side should be smaller. So the range for this node should be minus infinity to 20. And by the way, 20 cannot be included here. So the maximum we can have in this node is 19. Now, what about this node? What is the range of values we can have here? Well, here we can have any values from minus infinity to 10. Once again, 10 is not included, so the maximum value we can have here is 9. Now, what about 21? Because this node is in the right subtree of 10, the minimum value we can have here is 10, or more accurately 11, and the maximum we can have here is 20, or more accurately 19, because this node is in the left subtree of 20. Now, what about this node? Again, the value we store here should be smaller than 6, so the range of values for this node is from minus infinity to 6. What about this node? This node is on the right side of 6 and on the left side of 20. So the range of values we can have here is from 6 to 10, excluding these values. What about this node? Again, the value we store here should be greater than 20, and there is no limit in terms of the maximum value, so the valid range here is from 20 to plus infinity. And finally, this node over here. Because this node is on the left side of 30, the value we store here should be smaller than 30, and because this is on the right side of 20, the value should be greater than 20. So the valid range here is 20 to 30, but here we have 4. So using this algorithm, we are visiting each node only once. So to solve this problem, we need a recursive method. This method should take 3 parameters: the node we're visiting, the minimum value, and the maximum value. We use recursion to recursively traverse the tree and validate the value in each node. Now here's a question for you. What kind of traversal algorithm are we using here? Here we're using the pre-order traversal because we validate the root first, and if it's valid, then we look at its left and right subtrees recursively. So root, left, right. That's pre-order traversal. So go ahead and spend 10 minutes on this exercise, then come back see my solution.